All right, so today we have an old friend from a blast from the past, but who has a new company, Yucheng Low, co-founder and CEO of XetHub, which has the tagline "Stream large-scale ML assets in seconds," and also the only platform that provides version control for petabyte-scale repositories. So Yucheng, welcome to the Data Exchange podcast.
Thank you.
All right, so first question, what problem does XetHub solve specifically? And why do you think these problems or challenges are important?
Right. So to give a quick background, I was at Apple for a little while. We worked on building a centralized ML platform, and so along with that, we were a lot of teams, and we saw a lot of needs of kind of like data management, right? And this was a big problem, right? And so really, what we will provide is a versioning for models and data with kind of collaboration capabilities, which are familiar to a lot of software developers. Something we found which is interesting is like people talk about, for a long time, people want data to be like code, right? To manage data like code. We actually make that real, right? And essentially what we have is like it's a Git-based backend, but scales to terabytes, petabytes of data in a single repository.
So so the target here, use case, Yucheng, is mainly ML and AI?
Yep, the use case is looking at kind of a data scientists, machine learning developers, ML, AI for both like data management as well as model management to support reproducibility, right? And for instance, like essentially, one thing we see a lot in companies is unlike public machine learning data sets, which are golden, you make them once and never change again because everyone benchmarks against it. In a company, data keeps evolving, right? Whether I'm fixing or changing things or just collecting new data. And that's not really a good way to track or manage or version this. We like if I want to make a variation of the data for my own use, I'd really copy and paste, right? And then it's very difficult to collaborate and share and exchange and work with other people on these things, right? And so a lot of people just do with like spreadsheets, right? Google Docs or Notion or things like that. We see that quite a lot. And we already have solutions for this for code, and that's how we collaborate on code. And so this is how we do it, our backend of Git to support all of this.
So as you were describing this, some of our listeners might think that surely there's solutions beyond like writing tracking changes on a spreadsheet or a Notion document. So let's see. So there are solutions out there like DVC, for example, right? So what prompted you to tackle this problem in particular? So you mentioned this was a pain point at Apple.
Yep.
So, but when you start a company, you can't go by with only your experience. So surely you talk to many teams, right?
Right. Yeah, of course, like this is not unique to Apple. I think we see this as a pain point a lot of places, right? And it's like so many people do this thing where for the sake of reproducibility, right, they have a snapshot of their database, a copy of data every day, right? And that's really a waste of space, firstly, and it's just very painful to track over time. If I were to want to collaborate on like variations, we want to clean parts of the data, claim our variations, and that's just very painful over time, right? And so really what we have, one of which I think which really differentiates what we do is one of the core foundational tech we have is data dedupe. It should be cheap to store multiple versions, every version of your history, right? Even if you make changes in the middle, it should be cheap to store all these versions. It should not take quadratic space to store like 100 versions of data. It should be linear, right? Roughly in the size of the largest data, and that is one of the pieces we have. We published a paper about it. It's called Git is for Data at CIDR 2023.
So, quick question. So, what data types do you support? So I'm assuming you support, the things that modern AI teams tackle, like computer vision data and as well as unstructured text. So the reason I asked this, Yucheng, so as you know, several years ago, many data teams got concerned about their data, particularly with the advent of GDPR, right? So they needed to keep track of their data more and make sure they knew exactly where their data resided and documented and things like that. So there was some work mainly around structured data. So I guess there's two questions: what data types and what the key learnings from that GDPR era did you take?
Right, very good, a great question. Right, so we so interesting. So one of the systems we built previously was we thought people will want structured data, but we know that there's also images and other things, and we have an unstructured pool as well for data set sharing, right? And there's an example, and we found that basically everyone used the unstructured part of it, right? Just files, right? And this makes sense. It was essentially, we think about for machine learning, machine people, we deal with a lot of different file types, right? And some file types, some layouts are just because a tool we're using makes that file type, right? And so we take a very, very similar, which is files are the lowest common denominator, right? Even if you have like a structured data, Parquet, right, has become basically the de facto standard if you want to do queries on that, right? But of course, people will have images. People, like if we were to command crawl, we have this like WARC format, right? And so we don't really we take an unopinionated view of this. We can optimize for specific file types, but that's a later down the road thing. But because it's files, it means that we can just hold anything, right? And now the GDPR question is interesting. So what our platform, because it's not we're designed for data set sharing, there's a collaboration and so on. So something which we can do, is the ability to audit access. Right, and we actually and that was part of a thing we have built with our Apple. It's today is not this is something we are working on, and see basically who has access what data, who has access to repository, and all that. And what is really hard with GDPR is about data is data deletion.
Deletion, yeah.
Right.
I was going to ask.
Deletion is a very, very hard problem, right? And especially when it comes to this like big immutable stores, which like for instance is the Git repositories, right? Anytime you want to delete, you have to like rewrite all of history pretty much, right? So we have some ideas on how to tackle it. It's not something that we have today, and it definitely is something we are likely looking at, probably exploring the partners who have this challenge, but I think we definitely have some good ideas on how to attack this problem.
So the other thing that people care about their data, obviously, is some notion of openness and not being locked in. So open file formats, open source, or some degree of openness. So what can you tell us about openness in XetHub?
Right, and in fact, that in a way that's exactly why files are great, right? And as opposed to structured formats, if we do like tabular, just a SQL-like database, right? Then you have this weird question: okay, how do I export everything from this and load it in another SQL database?
Nowadays a lot of people use Parquet, right? So
right, exactly, because now it's just single flat files, right? It's just giant files, so and we pretty much only do it files, and so that means that if you want to migrate in and out, very easy. It's just a pile of files. Now, if you migrate out, you lose your history, right? But you can always go back in time and copy out those files as well, right? So migration is cheap. And then on the other side, we have actually open sourced all our client surface area, right? And this the intention is to make it very easy to integrate. Our server side, you think about it like S3 really.
So the file format is proprietary, but the interfaces to the files are open.
Right. Think about it like we just deal with any file you give us. So think about it like an S3 bucket, right?
Okay.
You just load files with us, but we have or a Git repository, you just put files. We don't really we can dedupe really any file type because we operate just on the file level. And then and then we don't really care too much about what the contents are, right? We can do like some clever things based on the contents, like summarization. We have like we do CSV parsing, so we can do like nice summarization on our website. But otherwise, it's just an S3 bucket with collaboration capabilities, as much history as you want, branching, and all the capabilities you expect from like a Git report, from like software collaboration.
So what about what about existing tools like Amazon EBS or Git has this thing called large file storage, or as I mentioned, DVC. So is there anything that distinguishes what you do from kind of some of these existing tools?
Yep. So we scale out massively, right? So that's one. So for instance, on the LFS side, there is, because the architecture just means that there's a reasonable limit on just the size of the repository. On the other hand, we have scaled the contents of repository to basically, like, I think our largest is now 10 terabytes right now, right? Just in a single repository, and you can just mount it, access it from anywhere instantly, right? That's one. The other is, which is a big gap from DVC, is that you don't, it's a little like LFS in that you don't have to think about what you want to store on using DVC or S3 or in Git. You don't have to think about the differentiation. You just write files to it. We take care of it. We take care of the dupe. DVC will do it on the file level, right? We do it on the block level, right? 16 kilobyte or approximately 16 kilobyte block. So what I mean is you have a CSV file, you insert lines in the middle, we can actually dedupe most of it. And we go like, hey, only this part changed. All right. And so that it is that ability that lets us manage, multiple versions of files without having to incur very much storage. And that also gives us a lot of performance, right? It means that on your client, if I were to download if I were to like switch branches, pull out a new version of my data, I don't have to download everything again, right? If I have a training cluster, right, we have a cache server deployment. We can deploy cache servers in a cluster, for instance. You are training on an older version of the data set. You can switch a newer version of the data set. You don't have to download everything. You can, most of the cache is still fresh, right? Because only the new blocks have to be fetched.
So you mentioned something about deduplication, but I noticed you also make a big deal about providing automatic summaries and visualization tools. So talk to us a little bit about some of these tools.
Right. So this is actually an area of investment, which is the question of, if I have a lot of changing data over time, right? And we're calling, or even models, right? I have changing new models and changing over time. How do I tell what has changed, right? How do I tell if my new model is better? How do I go back, hey, this model variation is better than this model variation? How do I compare those?
But that goes to the model monitoring and evaluation tools, right?
Right. Oh, right. There is part of the kind of the evaluation, right? But right now, if we just look at the static setting data about the models.
The model weights and the
Correct. If you just look
architecture.
at the architecture, or even the training metadata, all the curves and kind of, right. I want to be able to make it very easy for me to just go to one place, look at every version of the thing, be able to, just like Git you do with code, right? Be able to take, hey, this branch is this version, this branch is this version, compare them side by side, right? And see, hey, if you have a CSV file, hey, this column was added, this column, the distribution.
Which I guess is also actually ties into debugging and also kind of improving your model, right?
Exactly. Yeah. So people have we have talked to people who go like, I just want to see. They really just want to version reports, right? I run a regular report on my data, on my model, right? I have just this entire history of reports on my branches of reports, and just having a place where I can pull them up side by side and go, hey, this model is better than that model, right? In this way, these two curves overlap in this way, right? That is that is very, very useful, especially when your history gets long, as a lot more people are working on the thing, as a lot more teams are working on different experiments or variations of the model. All this becomes like just increasingly more important.
So you specifically focus on what version? So what is the main? How should data teams think about XetHub? Is it mostly think about it for version control or understanding your data, but not necessarily Yucheng in terms of using your data in the following sense, right? So imagine I want to build a custom LLM, and as part of that custom LLM, I want to do vector search. So as part of vector search, I may use an existing database with vector search or a new vector database. But long story short, I have another system that's doing kind of embeddings, right?
Right.
So does that mean then how do I think of XetHub? So XetHub is a way for me to keep track of versions of the embeddings, or I'm not using it to store or access or actually do the vector search, right? So what is the role of XetHub in my infrastructure and architecture?
Right. So I like to think about it this way, which is we store data which any data which you think you might want, which you think is of value and you will want to potentially come back to in the future, right? Or you're gonna use, or you can update, right? So for instance, for vector search, right? So for the purpose, you may come up with like new vectors over time, right? Improve vectors, if we're to change, I'm not going to use like this version of GPT and use that version of GPT, right? However, you always want to be able to go back and go, hey, I want to compare this combination of this model with this old.
That would be ideal if it didn't cost as much, right?
Exactly, right. And so this is pretty much where we come in. We give you the ability to essentially version your entire system together, right? Just as you might collaborate with code today, right? All these are just components of one system, whether you're gonna monorepo, right? Which is, hey, you have your model, you have your training data, you have your you have your vector embeddings, right? How do you make it so that all my developers, all my ML scientists can easily just access this, run this offline, do make improvements to it, whether your improvements are going to be on the vector database, on the vector embeddings, on the model, right? And then just check that in, push it somewhere, knowing that all your previous versions are still all accessible, right? So often, even just on like my own project, sometimes it's like, I do this ML thing, and then I accidentally overwrite a file which was the previous model. It's like, okay, what do I do about that, right? Or so come especially if I shared S3 buckets, right? Which is, you run the script always writes the same place. You happen to have permissions to the bucket, you run it, you overwrite, and then now what is the current model version of the model in production? What's the current version of the model which people are experimenting or are trying to compare against? And this just gives you the full confidence that everything you run, you can always go back in time. Essentially, the confidence to collaborate, right? And then I think that's basically what is missing on data today.
This would be the ideal scenario, but the reality is in the example you gave, right? So let's say I want to try new embeddings. The scenario might be I would do that in some sort of staging environment, try it there, maybe deploy it, evaluate it, and then when I'm ready to use it, I deploy that to production, and then the previous version of those embeddings are gone. Is
Right.
that right? So,
Right.
but so then which begs the question: why do I care to saving that previous version if if I just already showed, through careful evaluation in the staging environment that this is the way forward for me?
Right, but the thing is, there are just so vector embedding. There's so many cross combinations of all these things, right? It's like even for vector embedding,
there's the actual embedding. There's actually the how you do the embedding, right? So So the length of the snippets and stuff, right? So
that's how you do embedding, the contents of the embedding.
But the point though, Yucheng, is I'm carefully evaluating this in the staging environment, and then when I'm ready to push to production, I push to production. Do I really care about the previous version?
Yes, because just like essentially any distributed, any deployment system, right? The ability to roll back is crucial, right? The ability to be able to roll back to any point. We do this like infrastructure as code is one of the big things today, and it's actually kind of scary that you have you have a database which you are overwriting everything.
Well, maybe I keep that I'm able to roll back to the most recent version, but not like 3-4 versions before, right? So
Right. Yeah, you can maybe like roll back one version, but now I guess it's like, okay, if I'm going to go back, how do I collaborate on alternate versions of these things? Maybe I have a different team working on. Okay, I'm going to use a different embedding model. I guess a different way of doing doing this embeddings, right? And you have and now you're not just having like one embedding in staging and one embedding in production. Everyone is working on their on a different one. How do they collaborate? How do they work? How they work on these things, right? It's like, oh, you can spin up something for a small team, right? But if they're still iterating on their embeddings, they probably want to be able to keep going back and forth on different ways of using embedding, different versions and all that. And finally, I think the big thing is one thing is also about kind of like reproducibility, right? Which is ultimately you are deploying your model into production. You're deploying LLM or vector embedding for a reason, right? You want to be able to maybe do like summarization, whatever that is, right? Say you have Notion, I want to do summaries. Right? Now, eventually, so something like LLMs is it's still a machine learning task. So the whole process of doing like validation or testing, train test splits, and all these are still crucial, right? They are still just as important, right? You can't can't avoid it, right? And so if I'm going to come up with new versions of the vector embedding and all this, that's essentially thinking about it's a new model. It's just a different model, right? As I accumulate new test data, if I come up with new test data, I will always want to go, okay, how is my new model comparing, evaluating that against previous versions of the thing? I want to know that how my accuracy has changed over time. It's not only just on the old data.
I'm not overfitting somehow.
Correct, exactly. So what happens is when you have a vector database, your LLM model, the thing you're doing really is not just the LLM model, but also the entire vector database along with it. That is the entire thing which which is your ML model. And now you actually have to be able to store all that and be able to evaluate how that has the performance of that over time.
So what makes you, it sounds like the critical thing about your technology is this notion of deduplication, because it allows me to store multiple versions of the same artifact very, very efficiently.
Yes. So one of the core foundational pieces of technology.
So if you remove this aspect of the technology, then it becomes a lot more expensive, right?
It's not even just a lot more expensive, maybe like quadratically more expensive, right? Being one, and also there's along with that, there's just a big performance question there too, right? The dedupe also brings us a ton of performance benefits with for training and for everything else.
So what? Are you comfortable sharing like 2 to 3 kind of case studies? You don't have to name companies or use cases of this technology where it proved instrumental. So in other words, without XetHub, it would have been impossible to do what this particular team was trying to do.
Right. So I think we have we do have a case study published on our website, which is which a robotics company called Gather.ai, and they use our technology to manage model version history. Right, essentially all the different historical models which they have deployed and everything else with it. Right, so it's and there just pretty much out of the box we get I think we do a dedupe of 40%, and that equivalently just maps to just 40% faster deployments and everything along with it. Right. So that was just one of the.
So in that particular use case, why not just use Git?
Oh, because the repository actually ends up pretty big, very big. Right, so we get the dedupe. It's crucial. The dedupe and the scale is a big part of it. That.
So for people for ML problems that don't require deep learning, so the models are not gigantic, then I can get by with Git.
Up to a point, right? So Git has, of course, the maybe Git LFS up to a point, right? But I think there's still the question of essentially your data and then all the intermediate data that goes along with it, right? Whether you have Parquet process it into intermediate NumPy arrays, all those still has to be saved. All those you will like to be able to save and save them somewhere to reproduce for reproducibility reasons, right? And I think. Yeah, even for my personal projects, where I'm not necessarily doing a lot of deep learning, right? It's like, I would love to be able to just version my notebook, all the data that goes with it, just so that, or store that, just so that I can confidently run this notebook without it overwriting everything.
So we're talking about data, and models are kind of a form of data as well. So naturally, a natural question here is security, privacy, and access control. Yep. So tell us what you're doing in these areas.
Right. And so this part is we use an ACL mechanism that is very familiar to everyone, right? Especially everyone who's like software developers, which is it basically looks like GitHub. Right. In fact, and that is basically the level of access control, right? So, you share with teams. Some people can reaccess, and along with that is also just the collaboration capabilities come of it. If I have access to it, I can fork the data set. I can duplicate the data myself and inside my own brand, make my own version of it, and just immediately go off and just try it out myself, right? It doesn't matter how big the data set is, and I think that just adds it's just ACL and just a ton of collaboration capabilities. Your team has a data set. I don't want to touch your data. I fork it, I duplicate it, and then now my team can go on working on it without having to worry about that.
And so then that means, Yucheng, for people who want to try out XetHub, the UX or user interface is basically like Git.
Yes. Yeah. Although so we to make it, so one other key thing which I think makes it also a bit different from makes it very different from essentially from like DVC and things like that, is that we provide a bucket-like view of our repository as well. So we have put out a Python API client called PyZ. You can import it, and it's compatible with the FSpec interface. So essentially that means that you can just access any historical version of any data just right there in your Python code, right? Using z:// right? But similarly, there's also a CLI, which then you get ZCP, ZUpload, basically looks like AWS CLI, and we see and this just makes it very, very easy. We use it a lot internally actually to just upload and download data from a Z repository without having to go through Git. Turns out, so I love Git, but the GDPR is not the ideal place if I just want to like upload like 100 gigs of data to it, right? So yeah, but I can just on the command line just ZCP pile of files, whether from S2 or anywhere, straight into a repository.
But as we noted earlier, obviously there are certain elements here that are tailored for data and models, and one of this is the summaries and visualization tools, right? So deduplication and things like this. So for the summaries and visualization tools, so these are just basically like, let's say, like web apps that you can kind of drag and drop, very intuitive to use.
Oh, it's definitely still something we are working on. It's still kind of an early days on that. Today, what we have is we have a billion CSV summaries based on sketching, which is things I used to work on until we create right for GraphLab create, right? So and then on the other side, we have the ability to build and deploy a Streamlet app, right? And where the Streamlet app essentially has it's based on the file system. It has full access to all the data inside repository, and is able to do things there to visualize it. We have done that with, like, for instance, like DuckDB. So it's an app which you can just run. It basically imports DuckDB and runs it, and then now you can use just in the web UI query a pile of Parquet files, right, in the repository. Yeah.
So if I look at your data set, I fork it, or your mono fork it. So we both immediately benefit from this deduplication feature, right? So
it's automatic. You don't have to think about it.
Yeah. Which I guess the scary thing there is, if I start making changes, does that how do I know I'm not going to kind of delete some of your data? Or
no, we take care of it all. You just treat it exactly the same as you would as a bucket, or as a bucket, or as a repository. We have Dedup we think Dedup is a performance optimization, but a very important one, right? It is the performance optimization that allows growing data sets or collaboration to work, right? To even work at all.
And also, while storage is cheap, it's not free. So
yeah. Yes.
So there's a cost. There's a cost benefit as well, right? So
yes, definitely there's a cost benefit, but there's just this inherent friction, which goes like, hey, if I want to collaborate on this thing, if like say, okay, let's just say common crawl data set is on an S3 bucket, because I was just doing something in the CC News yesterday, right? It's on S3 bucket. I will just go to do anything to it. My first thing is download it. And now my first thing is to download it, or maybe I copy it to my own bucket. Now, the CC News data set is about 1 terabyte in size. That copy is going to take me a very long time, right? And that added friction just makes it that much harder to collaborate on this thing, right? And now if I'm going to clean it, for instance, I was finding that some of the very old CC News, the GZ files are not valid. They don't actually decompress correctly, right? And so, okay, now I'm going to clean it. How do I do that? Right, it's just that much more painful when now we have this bucket, we're gonna make changes to it. Okay, how do I know which files were touched when I cleaned it? Right, now if I clean it, hey, there's a new version. I can in the message goes, hey, we fixed this file, so I can compare 2 versions. And goes, hey, these 2 files were changed, and the reason why they were changed is because the GZD code was incorrect, right? And there's some problems with this file, right? And now we have very quickly, we can just have a data set which now, hey, if you want to collaborate on it, if you want to do your own variations on it, to clean it in your own different way, you want to filter it, right? The fork is immediate and do it yourself.
I was just thinking as you were talking, one demo that you guys can build.
Oh, I would love to have more ideas for demos.
So it's probably do something around archive papers, because it targets exactly the audience that might be interested in your tool. So if you have some kind of demo that shows something about archive papers, and that can't be that big, right?
We looked into it. I have not spent a lot of time into it. I think we have.
I mean, it's much smaller than Common Crawl. Let's put it that way.
It is. We actually have a full clone of the Red Pajama 1T dataset, which has archive, I think, as part of it, as a subset of it. I think that's again 1-2 terabytes, I think, Red Pajama. And you can just today you can just, if you want to run your own subset, clean it yourself, do your own filters on it, you can just fork it right now and go for it, right? The fork is like instant, like forking a Git repo and just make your own updates, make your own changes.
So right now, the best way to use XetHub, or the only way, is probably through your service, right?
Yes.
Your cloud service. And this cloud service is automatically scales out.
Yes.
Right? So it takes care of all as data grows. You don't have to worry about it. Infrastructure is managed. It's a managed service.
Correct. Yeah, it's a SaaS. It's a SaaS.
Yeah. And then what are some common integrations that XetHub has?
Right. Integration is something we're working on. I think depending on what kind of integration, I guess kind of like on the Python side, right? Always looking for new integrations, always looking for new ideas for integrations. We are of course looking with FSpec now, of course, and we are looking at we're looking at ML Flow as an integration point, which will then let us just very easily provide a lot of reproducibility, a lot of tracking capability on that. For both the input side and the output side, right? And I think we have a few other. We have a long list of possible integrations, but like just prioritizing.
And
that.
then lake houses like Databricks. Full disclosure, I'm an advisor to Databricks, but it seems like that would be a natural thing as well to integrate with some of these lake houses.
Yeah, I think we have some of that on the list, but I think for those, I think one of the link house is one of the questions is like, what exactly is the modality of integration? I think there's a lot of details which I think we have not quite when I got flash, and I would love if you to chat if you have idea, if you have
what
idea.
So in terms of, so is this, so obviously what you're saying is XetHub is something people might consider using even, even as a single user and stuff. But at what point does it become clear you need a tool like XetHub? Do you have to have lots of data? Like, are we talking about terabytes, or even at the gigabytes, you start clamoring for a tool like XetHub in your mind?
Right. It's definitely a great question, right? I think uh
Or is it mostly Yucheng, when I start working with more than myself, I have
yeah,
a team and
I think it comes down to the same question of like when do you start using GitHub for a software project, right? And you start using GitHub for a software project when you go, okay, I sometimes am overwriting a file I need, right? Or sometimes I forget the history of something I need, and I just want to be able to commit it somewhere just so I have the confidence that I can do something. I can just so I have the confidence of being able to go back in time, right? Or I'm now working on different variations. Or yes, exactly as if I'm adding one more collaborator to my team, right? And that's also kind of exactly at the
but
point.
size of the project matters as well, right?
Yeah, so we work well on we work well on kind of arbitrarily sized repos,
Sure.
really, and I think trying to show that we can do like terabytes and so on is a demonstration of scale, right? But I think like really, as long as you have, I think, more than one person, or even sometimes yourself, and the project gets a bit hefty, right? A couple of gigabytes. I can no longer store this in my GitHub repo, right? As I need something better.
As you were talking there, I just realized actually the need for a tool like yours is going to actually grow, because basically it's clear to everyone that they need custom foundation models and custom LLMs, right? So as good as the APIs are, people know that they will need a variety of LLMs in the enterprise, right? So kind of like a mixture of experts, optimized for very specific use cases and domains. So you can imagine these LLMs, even if they're small, so a small LLM may still have hundreds of millions of parameters, right? And so you can imagine enterprises having to keep track of all these LLMs inside the enterprise, the data that supports those models, who's working on those models, and so on and so forth,
Yeah,
right?
I see it. Actually, that's an interesting point, right? Which is, for a while, we have this new area, this new field we call ML ops, right? And it was kind of a position we put in the Gift for Data paper, which is ML ops is nothing else other than DevOps at scale, right? If DevOps can scale to the point where your repositories can be arbitrarily large, where your CI can deal with like ML training, right? Can deal with GPUs and so on, then a lot of problems just fall into place. There's a lot of tools you do not need today, right? And we're talking about like mixture of experts and so on. Is this evolution of machine learning ML teams towards closer to really like microservice teams, right? Service teams. Essentially, it's not it's teams working on one microservice, ML model as a service, ML model service, but people are querying it from everywhere else, and you have, just like microservices, you have like 10, 50, 100 of these things in an organization.
But they're non-trivial, because right, so they're non-trivial because these models are going to be non-trivial.
Correct. It's like
Right.
they're big and hefty. So existing DevOps solutions don't work. But if we make those things scale, and that's what we are trying to do here, just straight up on the foundation piece, the storage side, right? We make storage scale, right? We make storage scale to the needs of this kind of like services. Everything else will then much more easily fall into place.
So in closing, we're talking data and models, very important IP crown jewels for many teams. So you're guaranteeing you're not reading the data, you're not looking at the models and stuff. So
And of course, we do have the ability to deploy in your service. We have like so it's we run AWS, the best practice principles of
you're not
infrastructure.
going to it's not going to be like GitHub where suddenly people are up in arms because their code on GitHub is being used to train GitHub Copilot, right? So
Yeah, that's no, we are not looking at your data for sure. And if it Copilot, I think they only used the open models as an open data.
I mean, I'm a paid user of OpenPilot from the beginning, right? So
I see. Yeah, okay, yeah. So I think it's just a really open source there. So I think that one is a bit legally interesting. But anyway, we have we wrote our privacy thing to just be like, we are not doing good. We're not going to do anything with your data. We're not running ads based on your data. Yeah, we're definitely not going to.
Yucheng, so do you see your tools being used to kind of play a role in hosting some of these open data sets that are becoming important for ML researchers? It seems like your tools will be natural for that, right?
Yes, I think so, and that's kind of exactly the direction we are trying to push into. Today, a lot of hosts are Hugging Face, of course, right? But we see, and as we go towards collaboration on data, people who are taking data and just making their own subset variants of it, right, and things like that. And I think there's likely going to be a lot more interest in time evolving data, things which change over time, right? Like for instance, something which
because right now these massive data sets are basically download only. It's
correct.
there, I can download it, but there's nothing else, right? So,
exactly, right. And in fact, there's just one interesting one, which is like everyone uses this Lion 400M, right? But you cannot actually there's no one version of it because everyone downloads a different version of it, right? You just run it and you download the entirely
and Danny and Visual Layer have the best version.
We are actually collaborating with them running Visual Layer on just all of it. We have actually done all of it for legal reasons. We're trying to figure out like what we can do to is there anything we can do to kind of like collaborate on and share, because I think there is a lot of benefit in having like one reproducible version of it which everyone can evaluate against. But the legal
and like you said, right? So you can imagine these public data sets in a GitHub style repo where you can look at previous versions and
exactly,
and collaborate with other people, right? So have issues, have pull requests, right? So yeah. And with that, thank you, Yucheng.
Yeah. Oh, also find out I will be at AI conference.
Oh, that's right. Yeah.
Yes. So definitely hope to see you there.